Here's the calculator. If you want to just subtract these values, then go up to list 3, and we're going to be defining list 3 as list 1 minus list 2. Hit enter, and it's going to automatically subtract all the values and put them in list 3. Boom.
For list 1, I just kind of went in, and for each value, I put 245 minus 246, and then I put it 4.
Yeah, you can do it that way. This is this to me is a shorter way of doing it and making sure that there's not going to be any subtraction errors going on for you. So again, it's up in list 3. You're going to hit list 1 minus list 2. So far, we have our lists in our calculator. Step 1, we stated our null and alternative and said it was a two-sided test. It was a paired t-test. Our normal condition needed these graphs. Any reason to overturn that we're using a normal distribution? No, not really. Pretty linear here, pretty symmetric here. So that's your first 2 steps. Step 3, formula, which was up there, plug in your numbers, answer. You want to make sure you say your degrees of freedom. That's what your p-value should have been. So if you had done it this way, wherever you got your list, you're going to go stat tests. You're going to go down to t-test. Where do you have data to tell me out of a list, or do you have stats to give me? Well, I have data that I put in a list that I want you to use. Mean is 0. List, well, we put the differences in list 3, so I'm going to use list 3. Alternative is that we are not equal to 0. And there's your t-score and p-value. Make sure you put degrees of freedom as well. You can get the mean and standard deviation from there to put in your formula. So the p-value was less than our alpha level. Reject the null hypothesis is evidence that that there is a difference, or that the mean difference is not 0. So that is your 4-step process on this one. And that's it was scored basically in 4 parts as a 4-step problem. So each of them were earning either credit or not credit for those parts. All right, let's start. And again, I'm not going to write out every detail here. I just want to go over the broad points so that we're covering a little bit of everything today. Type 1. Type 1 would be rejecting incorrectly. So let's first talk about what rejecting would mean. Rejecting the null hypothesis means we're concluding the alternative. So that means we are concluding that more than 5% of the cars have the defect. So if we're doing that incorrectly, then that means we're saying that more than 5% of the cars have the defect, when in fact, they don't. What's the consequence of that? If more than 5% of the cars have the defect, what are the lawyers going to do? They're going to take a case, and they're likely going to lose the case. That's their consequence of the error. So stating the error is just, here's what rejecting incorrectly means. The consequence is, if they conclude that, what are they going to do? So in the on the other hand, and I'll show what these look like written out in just a second. On the other hand, a type 2 error is failing to reject incorrectly. So what does failing to reject mean here? Well, failing to reject would mean there's not enough evidence that there are more than 5% of the cars that have the defect. That would be failing to reject. And if they're failing to reject incorrectly, then that means they're not concluding that more than 5% of the cars have the defect, when in fact they do. When in fact more than 5% of the cars do have the defect. So what's the consequence? They don't take a case that they should be taking. That would be your consequence. So let's take a look at how that's written out so that you can see. Type 1 error. The firm believes that the proportion of cars that have the defect is greater than 0.05 when in fact it is not. Consequence, the firm will not recover its expenses, resulting in a loss to the firm. Right? That's rejecting incorrectly, concluding the alternative when you shouldn't. And then type 2 would be the failing to reject incorrectly. Law firm is not convinced, we're not concluding the alternative, that the proportion of cars have the defect is greater than 0.05, when in fact it is. When in fact the alternative, not concluding the alternative when the alternative is actually true. So the firm will miss an opportunity to make money on this case. And cars will go on having the defect in that way. So that is what your descriptions of the type 1 and type 2 errors should look like there. What this will look like is that the null hypothesis will be that P is 0.1. The alternative is that P is greater than 0.1. And then you're going to say P is the proportion of graduate students that would live on campus. And then you would give your alpha level being 0.05. Right? That's what you should say in your step 1. Null and alternative, define your variable, give your alpha level. That's what you should say in step 1. Step 2. Again, we're not going to write all this out. We're just making an outline. Step 2, this is a 1 proportion Z test. So we're using proportions, we're using Z-score, and it's a test, not an interval. So random, normal, independent. So the biggest thing, survey with a random sample. There's our random. We have a large university, so 10 times the 481. That's probably our independence. And then our normal, to check our normal condition, we would check n times p naught, and n times 1 minus p naught. Remember, our whole distribution is assuming the null hypothesis is true. So our n times p naught would be 481 times 0.1. I don't use p hat until I get to step 3. That's 48.2, and then this one's also going to be at least 10. And that's what you would check for your normal condition. In step 3, formula, plug in the numbers, answer. I'm just going to write out the formula to show how we're going to get that overall structure. It's a Z-score formula. So basically value minus mean over standard deviation. So our value here is p hat. Our mean would be p naught. Our null hypothesis saying that that p is 0.1. Over standard deviation. Our standard deviation formula also relies on p naught. It assumes the null hypothesis is true. So the standard deviation formula for proportions times 1 minus p naught over n. That would be our formula. So the last thing I want to do here before I take questions is make sure we can get this out in the calculator. So go onto your calculator. It's going to be one proportion z-test. And make sure your answer matches mine. And if it doesn't, let me know in a minute. Stat tests. Down to one proportion z-test. B naught was 0.1. And then our x of and n. So we have 62 out of the 481. So that's what we're going to put. 62 out of the 481. Our alternative was that P was greater than 0.1. So there's our z-score, there's our p-value. So we're going to end up rejecting our null hypothesis. So that's the quick outline of the four-step process on that problem.